Hi all. So we are going ahead with our Jaipur chapter, and we have Apurva Saxena, who's the director, DevOps, D. Curtis Corporation, and he will be talking about the understanding the importance of full-featured CI/CD pipeline. Just before we go ahead with this chapter, let me quickly thank our founding sponsor, Innovation Roots, which is a leading consulting and training service provider helping organizations to achieve business agility and beyond. It is one of the leaders and pioneers of niche publishing services and well known for content collaboration with global thought leaders, authors, and creators. For more details, you may refer to www.innovationroots.com. I would also want to thank our sponsor, Agile. Agile is a product offering from Tata Consultancy Services Limited. It is a purely cloud-based enterprise agile planning tool along with DevOps capabilities. Enterprises can use Agile to adopt agile practices or scale across multiple Scrum and Kanban teams using enterprise scaling frameworks such as SAFe, Disciplined Agile, LESS, and more. You can also try out Agile for free up to 20 users for 30 days by signing up at agile.io, or you may reach out to us for more inquiries or exclusive product demos. Check out our Agile page on Agile Network India website for more details. You may check our chat box as well for the link. Quick do's and don'ts for our participants. I would request you all to join 5 minutes before the start time. I would request you all to use high quality speakers or headphones for better sound quality. Please keep your microphones muted and videos disabled as this may cause disturbance and bandwidth issues. Questions will be taken via chat box. I request you all to put your questions in the chat box at any point of time during the session. And at the end of the session, our facilitator or moderator will help and read out the questions to the speakers as per the time availability. I highly recommend you all to fill in the feedback form, which will help us understand more about the event management. We appreciate your cooperation, and with no further delay, let me call upon Nupur and Apur onto the microphone and the webcam.
Thank you so much, Navina, for the introduction. And hi, Apurva. We are looking forward to this discussion. And it is an interesting topic, DevOps being widely implemented across different organizations. It is very important for everybody to understand CI/CD and learn how to set up the pipelines. And I think it won't be wrong if I say that CI/CD implementation is the backbone of modern DevOps environment because it bridges the gap between the development and operations team. And we are looking forward to explore more about the full feature CI/CD development with you, Apurva. Over to you. Looking forward to lots of takeaways. We'll have the discussion for approximately 30-40 minutes, and then we can pick up the questions at the end of your session. So I'll read out those for you.
Okay, all right. Thanks, Nupur. Okay, hi everyone, let's start. So first of all, who I am and what I do. So my name is Apurva Saxena. I've been working in this DevOps world since 2018. But I started as a .NET developer for the backend side and then worked on UIs as well as the backend and some form of database, also kind of full stack developer. Then I moved my role and to a technical architect. Then at some point of time, I did project management also, and then eventually moved to DevOps side of things. And right now, I'm looking after 3 areas. One is network and security department, one is DevOps, and third is customer deployments. So I've been working with Curtis for almost 11 years. It will be 11 years next month. And before that, I worked briefly in Pune for a couple of years. So this is what I do in terms of daily is mostly on how things are, how the deployments, how the environments are running, as well as how is there any problems or any new requests from customer sites for the environments, as well as keep on a fine eye on the security for customers as well as our environments. Now, who can benefit from this session? I think everybody who is part of the software development lifecycle can actually benefit from this. What I'm trying to explain here is that how just one feature of, say, the bigger DevOps term, which is CI/CD, can actually help everybody's life here. How you can actually smoothen your development, testing, and deployment. So this is, I think, so audience can be everyone. So I think I thought that before actually going and understanding what is CI/CD and what is DevOps and why you should actually go through what I'm suggesting, I think you should know the background and use case of what we were doing and how we actually reached here in terms of Decurtis. So Decurtis, we actually started working on our product or the platform in 2016. And at that time, we decided that we will create a platform with 150 microservices. We researched everywhere on starting from Netflix to other companies, like how they have done microservices, what should we do, and what tools should we start with. So we first designed and we created, designed the database and the services. That is on mostly on the architecture side of things. So we were looking for deploy 150 to 200 microservices in one go in one environment. So that is our use case. Previously, when we were doing the build, deployment, and IT operations, what we were doing was there was Jenkins always there, and the Jenkins was creating the builds, but it was just creating the builds. The deployments were mostly manual, and then we had the separate department for IT operations, like who can provision the machines and who can provision the access rights and all of those things. So this was happening on our data center in Jaipur only. And but when we move to this 150, 200 microservices world, obviously the Jaipur data center cannot support that. So we decided to migrate to cloud. And at that time, we chose to go to AWS. I don't think there was any specific reason to going to AWS. It was the best one available at that time. So we just decided and went to AWS. So this is all happening in 2016, and we were reading about microservices and everything. And then we, started reading more about DevOps and CI/CD and all of these things. But what we actually did was, I think it was a mistake on our side. What we initially thought of DevOps was, okay, DevOps is somebody who will create the CI/CD pipeline and can just keep a, will be a bridge between operations and development. So any person who is responsible for the build creation and the deployment of things is called DevOps. So what we ended up doing was we had our engineering team, then we had our DevOps team, but we still kept the IT operations team. So the machine provisioning or the infrastructure provisioning and everything was still done by IT operations. DevOps was just handling two things, the CI/CD pipeline as well as the infrastructure components. And by infrastructure components, I mean we included Kafka, we included Zookeeper, included Redis, and Kubernetes came in picture and all those things. So we defined the role, and based on that, we created a team. So we had three, instead of two teams we previously had, we now have three teams. And that's how we started working in the DevOps area. Now, when we moved to CI/CD pipeline, we actually kept our old methodology of build deployment, and it's just that we implemented the same thing to all the 150, 200 microservices with one job, per service managing that. So this we initially started in 2016 to around 2017, 18, we were in this state only. This was the problems we faced. After everything was done, we were developing, but there was a major. These were the 10 major problems that we were facing on a daily basis. So I think most of you guys will be familiar with this. It's part of software development life cycle only. So first and foremost, the biggest problem was whenever an engineer was committing a code to master or merging a PR to master, they were not able to test it. And the biggest reason for that was because we had this big infrastructure. So what we did, we created a development environment and a QA environment. Now, on the developer environment, we had around 70 to 80 engineers working on a daily basis. And they might be working on different microservices, or they might be working on the same microservice. And because of that, they were not able to fully test their code. So they developed something, they deployed on the dev environment, and then they are testing. But at the same time, somebody else is also doing something, maybe in the development area or maybe in the testing area. So there was a high possibility, and we actually practically faced that every week or so, there was a bad check-in, a bad commit that actually went into the system, and then everybody from engineering or DevOps and database had to sit and then maybe try to roll back, which was not possible at that point of time. So we had to fix that problem and do a new commit. But at that point, everybody's work was hampered, because if a bad commit has came to the system and the system is not able to run, maybe the flow is not running for the platform or the application. So because of that, everybody, all the 70 to 80 engineers, they cannot do anything on the environment. So that was the biggest problem for us. The second problem, as I mentioned, rollback. So another problem related to rollback was backward compatibility. So now, because an engineer is working on a microservice, there was an API and they updated that API. They don't have any test. I mean, yes, unit tests are there, but they don't have any functional test uh, to check if what they changed, what is the impact of that particular API call from that particular microservice to the rest of 150 microservices. So that was a problem. And again, the third problem that we faced was again related, is mostly that quality gates. So we had Sonar. We use Sonar, I think from 2015, we moved to 14 or 15, we moved to Sonar. So we are using Sonar from since then, but it was a very basic Sonar analysis. So we were calling it Sonar quality gate, but Sonar and unit test cannot be the quality gate unless because they run on static code. They don't check the functionality of the code while it is while it is deployed or after the deployment, as well as backward compatibility and all those things. So yes, we had a quality gate, but it was very low bar quality gate. Again, we discussed about stability of multiple environments. Then there was another problem, which is promotion from one environment to another environment. So consider that we have deployed everything in dev, and now we want to do it, take that to QA environment. So the basic problem with these 150 jobs that we created in Jenkins and Spinnaker, what happened is we were we will have to actually manually run them. That okay, go ahead, and we have a release of 40 components, so we are manually running those 40 jobs, and that takes time. And then you have to coordinate, okay, first the database needs to be updated, then the configuration needs to be updated, and then the actual deployment happens. So Ideally, it was taking around couple of hours, but there were several instances, not just one, several instances that it was taking days also. So like we updated something on say Thursday and we were not able to fix it or properly deploy it by the end of Friday also. So yeah, this was another problem. Then because we were doing this from dev environment to QA environment or QA environment to our prod environment, which is our demo environment also. So if we are deploying and some problem occurs, and then we have to pull in engineers and database engineers and everybody. So everybody's time was wasted. And so they were not able to focus on the sprint work at that, I mean, in this particular time frame, as well as demos were running because say there we had to actually plan like this. Okay, there is a demo to a new prospective customer, say in next week. So don't touch the environment for this week because it might broke and then we will not get time to fix it. So because of that, we were not able to show our new prospective customers the latest feature set. It was always something latest -1 or -2 kind of thing. Then I mentioned and discussed that multiple Jenkins and Spinnaker jobs. So Spinnaker, I think Jenkins everybody will be familiar with, but Spinnaker is a specific tool. So I just wanted to give a background. Spinnaker is a tool created by Netflix for deploying to Kubernetes. So Kubernetes is just an orchestration layer to run Docker containers. All our microservices were running in Docker containers. We chose this path because it was actually easier to manage instead of deploying jar files directly to the VMs. So Docker was a much easier way to manage and deploy each microservices in their own existence. So Spinnaker and so we had one job for Jenkins, one job for Spinnaker per microservice. So this was a maintenance problem because if a new component comes, a new microservice comes, then we have to create jobs for both the places, as well as if we are upgrading something, say there is one specific configuration that needs to be updated for all the services, then we are doing it 300 places. So again, this was the problem. Because of this, we have to manage multiple tools because we had Git, we had Jenkins, we had Spinnaker, we had Kubernetes. All of this were being used for the environments. So we had so many tools, and because of so many tools, we require so many resources. So at one point of time, we had 20 plus team members in my DevOps team. So it was a lot of wastage of resources because those 20 folks were actually doing manual work, and if a DevOps person is doing a manual work, then by default you are doing it wrong because DevOps should always focus on automation. Their primary focus should be automate something and then give it to the team. They should not be responsible to run or execute something. They should be responsible to manage and maintain something. So we were not doing it correctly. So yeah, the last one I already discussed. So these were the problems, and I think we lived in this world for a couple of years before we decided and moved. So when we were thinking of moving. We created some pointers that, okay, these are the expectations. This is what we wanted to achieve. This is bare minimum we wanted to go. And whatever we design or whatever we bring to the table should always all these expectations should be met by that solution. So the first and foremost, CI should be running water. Nobody. So it's very simple. And in the US, they always say that something like logging should be like plumbing or something like that. So the reason of saying that is that in a day-to-day life, you don't worry about if the water is running or not, because this is the basic essential bare minimum thing. So you actually forget about it, that there is water running through the taps in your home or not, because you always expect it to be. And this was the bare minimum, because we had spent so much time on CI in terms of engineering and in terms of DevOps or in terms of IT operations, and maybe because this was impacting sprints, so project managers and testers and everybody was involved in this. We wanted everybody to forget that there is a CI pipeline. They should not worry about it, think about it. It should be like the essential regular things that we do in our home. Okay. The second one was quality gates should stop all bad code before merge to master. So there should be a way that we should be able to test the code before we merge to master, so that we know that when the code is actually merging to master, that is a good code. We will obviously test it again, but at least at one point, we are able to test that, okay, what we are actually merging to master or committing to master is a good thing. The third point was backward compatibility. Compatibility should be maintained. So again, it is actually related to the second one only, but we wanted it to be mentioned separately because it was a big problem for us that all the APIs or all the microservices should be backward compatible. So it's not something that, okay, I updated the database and I have to upgrade the API service, or I updated the database and I broke something and now API and service is not matching. API and database are not matching. So those kind of things we wanted to totally avoid those. The fourth point was there should be daily upgrades to our prod environment via CD. As I mentioned, we were waiting for at least sometimes 3 weeks, 4 weeks for the deployment to happen on our demo environment or prod environment. So we wanted it to be daily. The reason was that when we were showing the demos to our prospective customers, they should always see the latest features. And so that was another point. Next, engineers should not be bothered about deployments to multiple environments. This is another point where, as I mentioned, that because there was multiple deployments happening for multiple environments, we were not able to deploy in a very efficient manner. And because of that, the engineers need to be pulled in, the database team needs to be pulled in, and everybody needs to be pulled in because there were so many issues happening. So say we executed the database scripts, but then when we were doing the configuration, say we missed one configuration value, and then we did the API, and then all hell broke loose, and then we have to all sit and fix that. So this was again the biggest bare minimum, that whenever the deployments are going on, engineering should not be bothered because they should focus on their sprint work. As soon as the code is merged to master, they should not worry about how the code will be deployed, how the code will be tested, because that's not their problem anymore. Each engineer should have their own developer environment. Now, this was one of the biggest problems for us. 70 or 80 engineers working on a daily basis. They wanted to test their code, but they cannot test their code and certify their code if there is only one dev environment. So we decided, yes, it will bring in cost for us, but we have to do it, that we have to give every engineer their own environment. So every engineer running 150 to 200 microservices in a separate environment, which is actually owned by them. They can do anything on that environment. So I will come back on this one in a future slides, how we managed to do it in a cost-effective manner. Then again, it is not a bare minimum thing, but we expected that whatever solution that we are bringing should support at least next 5 years, considering that there was a huge resources we spend in terms of money and in terms of manpower to actually set it up. So we wanted it to be maintained and scalable at least for next 5 years. Next 5 years, because technologies change, your product change, your product's requirement change. So you have to keep that in mind. But at least minimum 5 years you have, then you are not spending the same amount of resources every 2 to 3 years. And another problem when you change, because there is a big term called change and organization change management. We don't hear about it. It's for big organizations, but there is a thing. Whenever you change something, not everybody is happy about it, and which is obvious. But if you keep on changing something every 2 years, so like we brought a CI pipeline in 2016, then we are redoing it in 2019, and now if we are redoing it in 2021 and 22, then everybody will think, okay, these guys are not stable. They just keep on changing the things, as well as they will they will think that, okay, now it's again 3 years, they will bring something new, and then we'll waste a lot of my time. So instead of that, we wanted to have at least 5 years, so that everybody will have a confidence that, okay, this is something that is will be there, and will not have to worry about it every couple of years. As well as it should support multiple clouds. The reason of multiple clouds was we were in AWS, and what we did is we kind of got married to AWS. We started using their services and everything. But we decided that when we are writing this, it should be run everywhere, right? We should not be dependent on a cloud. We should not be dependent on a data center or a technology. We can run it anywhere we want. So the first step was we actually wanted to move to another cloud. So we moved to GCP instead of AWS. And I will talk on the later slides on this. So very briefly, I just wanted to show what was our previous model. We discussed, but I wanted to actually you guys to visualize what we were doing. So you can see there are three starting points here. First is Git repository of microservice code. The second is Git repository of database code, and the third is Git repository of configurations. So we were managing these three things separately. Git repository of microservice code was like 150, 200 repositories for all the services. Git repository of database code was one repository with all the databases, and Git repository for configuration was one repository with all the configurations for all the microservices and databases. And the flow was whenever the code of microservices, there is an update and there is a merge to master, a Jenkins job, which is per repository, will be called. That will create a Docker image, push it to the Docker repository. We were using JFrog at that time. And then it is available for Spinnaker to deploy to Kubernetes. Now, there were two things. On the dev environment, it was directly deploying. And for any other future environment, higher environment, it was always a manual effort that you have to click those 150 buttons to deploy the code to say QA environment. Then for the database one, there was nothing automated there. You just merge the code to master just for safekeeping, and then you can run the manual script per environment. And the same thing with the configurations also. All our configurations were in Kubernetes config maps, which is the by default configuration which Kubernetes suggests or recommends. But it is very basic. So So this is our whatever we were doing. It is pre 2019, pre 2018 rather. Okay, this were the decisions that we took while moving to the new pipeline. I will show you the new pipeline in a future slide. But before, it's like I wanted to tell you what we decided and why, what's the use case of that. So first is why we moved to GCP. It's a very simple decision we wanted to take was AWS versus GCP versus Azure. The first and foremost was our infrastructure was running on Kubernetes. It still runs on Kubernetes. We wanted to have the best managed service available for Kubernetes, which is Google Kubernetes Engine, because Google maintains Kubernetes open source project. So we decided to move to Google Cloud platform. So it's a very simple decision. But what we benefit from going to Google was cost efficiency. This is, guys, not on record. I'm not saying that Google is cheaper than AWS, but for our use case, we saved around 30% of the cost. Second is we removed Spinnaker from our pipeline. So we discussed, we tried everything with Spinnaker, tried to automate it so that we don't actually have to click buttons. Spinnaker has improved a lot now if we talk about 2021 versus 2018. But at that point of time, Spinnaker was not providing us so many automated options. The automated options that Spinnaker provides was always dependent on having one job per deployment. So I have 150 microservices. So even with the automation, still have to create 150 jobs. As well as we wanted to move to Helm charts. Spinnaker was supporting Helm charts at that time also, but it was a very basic support, and we wanted to move to Helm 3 instead of Helm 2. So again, this was a decision that we took, that we moved away from Spinnaker. We still kept Jenkins at heart of CI/CD and CT pipeline. The reason for that is, first is we were very much familiar with Jenkins. Jenkins is a very easy open source, very configurable tool. The reason for that is there are so many teams or so many engineers or contributors working on Jenkins, so many plugins. Whatever you think of, you can do that with Jenkins. So we don't wanted to go away with that. So we kept that at our heart of our pipeline. Why we chose Git Flow versus GitHub Flow for branching strategy. So it's a controversial decision that we did. Everybody thinks that when you are working and there are two ways to actually manage your branches. One is you can have your master branch, and then you can have all your releases branches, and then you have your feature branches which developers can work on. They are temporary branches, but with each release you are managing one release branch, and after the release happen to production, that release branch gets promoted to the master branch, but you're not always writing anything to the master branch, it's just coming there. So you have the option to go back to any release. The problem with us is, as well as in terms of CI also, if you have 150, 200 components that you wanted to deploy, you cannot version them together. Obviously, you have to keep them, their separate versions. But if you create a release, so then you are not doing a continuous deployment. Right now, if I take and I deploy it to QA environment or production environment or any other customer, we cannot have a daily release kind of thing. Release should be tied to a sprint. When the sprint work completes, then you can call it a release. When for a daily CD continuous deployment happening, then you cannot call it a release. And that's why what we did is we will keep just the master branch, and all the feature branches. Whenever we test, the PR is created from feature branch to master directly, and then we merge to master. How we manage the versions and the releases is by git tagging. So every successful merge to master will create a new git tag with the updated version. So that is how we wanted to go further with our releases, I mean branching strategy, and that's what we chose. One master branch, temporary feature branches instead of per release a branch. Okay, this was a very big and very hard thing that we had to do, and we decided that okay, we will be doing this. We decided to keep one Jenkins job for complete CI for all repositories. So imagine we have 150, 200 repositories where the code is in Java, .NET Core, some were Python, Node.js, React.js, and we wanted to have only one repository, I mean, only one Jenkins job for all these repositories CI. So yes, we had to create some switch cases, specific case conditions for the technologies, but because we know that the major portion of the CI will always be the same, which is build, create Docker image, push the Docker image to Docker repository, create Helm chart, push the Helm chart to Google Cloud Storage, create database scripts, push the database scripts to Google Cloud Storage. So this was the basic thing. The only thing that was changing was how the compilation happens or how the build is created per technology. So that we managed by the switch case, as well as because the code was going big, because we have one job we created. I mean, we used Groovy initially. Now we have moved to Python, but initially it was Groovy, and we created classes, and we managed it in functions so that the code is manageable. Okay, why we added merge checks for pull request? So as I mentioned, we wanted to stop all kind of bad commits. We wanted to stop all kind of backward compatibility issues. So we have to have these merge checks for all pull requests. So by merge check, what I mean is, say I'm an engineer and I created a feature branch from master. Now I did my code, I tested, and I wanted to merge this pull request to master. So I will create a pull request, send it to the reviewer. So what we did is we have a panel of reviewers per technology. So only those folks can actually merge to master. So that is one level of security. But again, the second level of security was we did an automated pull request testing that I will discuss in a future slide. That whenever a pull request is created, we will test it thoroughly. Only after that particular test is passed, a reviewer can actually merge the code to master. Before that, nobody can actually merge the code to master. So this is what we did. The next was the database scripts in the same code repository. So instead of having one repository for all the 70, 80 databases we have, because each microservices had their own database if they wanted a database support. So we moved their database to their repositories. And the reason for that, I mean, database code. The reason for that was that previously database was managing their own version and the microservice was managing their own version. When we actually merged them, what happened is now the database and the API both have the same version. So it's easier to deploy, easier to manage, easier to maintain. And that's why we did this. Again, the next one is configurations. All our configurations were lying in one place, which was config maps. It was a one long file of I think 2500 entries, and or maybe more than that. So we moved those configurations to the database per component. Instead of giving all the configurations to all the components and config map, we bifurcated, and whatever was used by which microservice, only that service will get those configurations kind of. So that's what we did. So these were the decisions that we made while going and to the new model of CI pipeline. So yeah, before moving to the CI pipeline, let's talk about the developer environment. So as again I mentioned, 170 to 80 developer engineers, they won't want their own developer environment for obvious reasons. And the three main things that we wanted and what we did is a fully functional on-demand environment in Google Kubernetes Engine. And it's actually very easy to say that, okay, I wanted to give 80 people their own environment in Kubernetes. But what we eventually ended up doing was one Kubernetes, and each engineer environment was running in a separate namespace. So we had separate node pools per developer, per engineer, separate namespace per engineer, their components deploying there, and since it's on demand role-based access control given to that particular engineer on that environment. And they have the ability to connect to database, they have the ability to connect to Kafka, they can do anything, they can turn off anything, they can deploy anything in that namespace, but only in that namespace. And because we don't wanted everybody to learn Kubernetes, so we managed it through the Jenkins jobs. So we created few obvious jobs, like you want to deploy a component, you want to scale down a component, or you want to update a configuration, you want to restart something. So basic jobs we created, and if they want to do some advanced work, they can actually connect to kubectl and do their work, or they can go to Google GKE's console. It's a very nice dashboard, so you can actually do pretty much everything from there. So this is how we did. And I mean, we actually increased our GCP bill at least 20-25 times when we did this. But eventually we learned and we optimized it, and we came back to the almost same cost we were paying in AWS before this also. So we used on-demand environments. So a engineer can actually request an environment. The environment is available for 12 hours if it is on a weekday. It is available for 6 hours if it is on a weekend or in nights. And after that, it automatically shuts down, and it shuts down its resources also. So yeah, this is what we did in the developer environment. So it's a very good thing if you are not giving your engineers an option for their own specific environment, or if you have a specific problem like ours that your engineers cannot run everything on their laptop because their laptop is limited 16 gigs or 32 gigs of RAM. But all right, so the problem, like if you have a problem like ours that you cannot run your whole infrastructure or whole environment on your laptops or desktops, then I would recommend that each engineer should have their own environment. And we have seen after giving that, there's so much efficiency improvement because they are not dependent on each other, as well as the quality also increased because they can test the way they wanted, and whatever time they wanted to take also. It's not that, okay, there's one dev environment and I want to test something, but I have only 30 minutes because everybody will be hampered if I take more than that, or I have to tell everybody, oh, there will be a downtime because I'm updating this service or this API, and it can break everything kind of. So now it's their environment, they can do whatever they want, they can break it. Even if they broke it, they can just run the job, delete the environment and recreate it. And so it's a very nice thing. They even some of few of our engineers even take their database backup, and they just restore the next day on the new environment so that they can continue using the same environment for multiple days, like whatever the data they have generated and they want to test, as well as once the environment is done, they are working on a feature. That feature is completed, they're moving to another feature. They can just kill that environment and move to the next one. Okay. All right. Let's quickly go to this pipeline. This is what our final version is. This is what we are doing right now for CI. So I will quickly go through that. I just realized we are almost out of time. So engineer spins up a developer environment, creates a feature branch from master. We are using Bitbucket. You can use GitHub. You can use any kind of Git. They write their code, test their code locally, and commit to a feature branch. That is their branch. Deploys this code branch goes to the developer environment, which they have already spinned up. The code will be deployed to this environment only after Sonar and unit tests are passed. So whatever unit tests are there and Sonar, this gives engineers an option that when they are deploying to developer environment, the basic necessity of Sonar and unit test, and we are not asking about new unit test. It's that whatever unit tests were already there, they are passed or not, and the Sonar quality gate is passed. They can test the code, and then they can run a end-to-end Python test. So what we did is to test all of this, we created set of 500 automated Python tests. They test the whole functionality of the platform from start to end, so they can be run at any point of time against any environment, because it's just a configuration for them. So run Python test. If the Python tests are passed, then developer can create a PR to master. They create a PR to master, send it to reviewer. But as soon as the PR is created, Bitbucket pipeline calls a PR job in our Jenkins. And now the picture starts for CI. That Jenkins jobs create a full-blown environment like the developer environment with whatever the released versions are there. And once that environment is created, it will deploy the new code. So I was working on microservice A and I created a feature branch. So before I want to merge that to master, I create a new version of that feature branch and deploy it to this environment. Then I test again the Sonar and unit test. Then I run E2E once end-to-end tests are passed. Then I post a status back to Bitbucket. This Jenkins job post a status back to Bitbucket. Once that is done, then only a reviewer can actually merge the PR to master. It will send all kind of notifications, and that is dependent on your use case. Maybe Slack, we are on MS Teams. It can be anything. It can be email also. So that can be done. Once that is done and the PR is merged, the same process starts. But there is a slight difference. In PR, what we were doing is we were testing the upgrade. So I had the existing environment and I'm upgrading one component just to check. But in CI, what we are doing is, because the CI is the code is merged to master now, and the Jenkins is calling, I mean, the Jenkins job is called for running the CI. It will first create a new version via git tag. Okay, this is the new version now, and I'm testing this version. It has not marked as passed or failed. It's just created a new version, a new build version. Once that is created, it will create again, it will spin up a new environment like developer environment. But this time, instead of upgrading the component, it will start as a fresh environment. So it will use that version in creating the environment. So what we achieved by this is we tested our database scripts as a new installation as well as an upgrade also in the same flow. And it will create a Docker image and push it to a Docker repository. It will create Helm charts and database scripts in a zip format and place it in GCR, then spin up a new environment, run C2E. If it is passed, then take that version and mark it as a released version. And we keep this as a released version for our future environments, I mean, future deployments. This is quickly CI pipeline, and I'm moving to a CD and continuous testing pipeline. So there's a nightly job that runs E2E on the QA environment first, check check everything that is running. Then we have a set of Selenium tests that we run on the QA environment. Once those tests are passed, we promote this code to prod environment from QA environment. Again, run both kind of test, E2E and Selenium tests, and then send a message to release team that okay, prod/demo environment has been upgraded. Once that is done and passed, then we call uh, a second nightly job, which is deploy, which actually takes everything from our released version list and deploys to QA environment, run E2E, run UI tests, which are Selenium, and then send a message to our QA team this time that okay, QA environment has been upgraded. If the first one fails, the second one will not run because the QA environment is not stable, and we don't want to upgrade it before talking to the QA team. And in this case, the QA team can actually run it manually anytime. It's just that it is available nightly, automate in an automated way. The first one is updated by release team, and then that release team can run it anytime, but there is an automated way also. Now, the good part about all of this, the developer environment, the CI, the CD, and the CT, no DevOps team member is involved in this. They just create and maintain, and they are called only when something break in this. On a normal day-to-day life, nobody calls a DevOps guy. So yeah, I think that's it, and we already ran out of time, so we can move to QA.
Hi, Apu. That was an amazing session. Yeah, we are 2 minutes over the session time, but I would still like you to take at least one question. There are a couple of questions that's been asked by the participants, so let's just try to answer quickly because we are over time.
So
Priya
yeah,
has asked.
go on.
So Priya has asked, was the move to cloud based on any reason?
Yes. The move to cloud was because we wanted, previously when we were on AWS, we were managing our own Kubernetes, and it was creating problems that whenever you manage something which is already available as a service and you are still paying the same price. So we were uh, okay. So we were in AWS. My camera got stopped. Okay, yeah. So we were in AWS and we were using Kubernetes via KubeADM. First, it was not giving us high available cluster. The second, it was not giving us any kind of automated management, as well as AWS was not helping us. They initially started EKS, which is a Kubernetes service from AWS, but it was not good enough. So we decided on the three managed Kubernetes services in three different clouds, AWS, Azure, and Google. And we ended up going to Google, considering Google manages Kubernetes open source project. So they kind of like the biggest contributor for that. So we wanted to go to Google to use their service. That was the biggest reason. Everything else can be a byproduct of that, but this was the basic reason for moving.
Sure. Thank you for sharing, Apurva. And in the interest of time, we'll not be able to take more questions. We will be taking those questions offline. Thank you, participants, for asking such amazing questions. We'll try to get them answered by Apurva offline and share with
Right.
you. Once again, Apurva, for being with us on a Sunday morning and sharing such wonderful experiences with us.